Hello and welcome to part 3 of my model view model series and how to combine this architectural pattern with JavaFX. So we have talked about so far the concept and the idea and purpose of the MVVM, and in part 2 there was something about how the different parts involved, the model and the view model, how these parts interact and communicate with each other. So far it has still been on a fluffy theoretical level, but in this part we are going to introduce the UML diagrams and how to structure your classes. And the intention is that this will be sort of a template that you can apply to all your programs where you use JavaFX. The question is there some kind of best practice for JavaFX? And we haven't really been able to find much guidance about how to structure larger JavaFX applications. So what follows here is something my colleagues and I came up with. Our JavaFX MVVM is inspired from what you might see in .NET or Android development, but it's slightly different than what you will find elsewhere, because of the way JavaFX works, but there's still a large overlap. So if you familiarize yourselves with the concepts and ideas in our videos here, then hopefully you will find it easier to apply this in your future courses where you will see similar approaches. So we've seen a bunch of fluffy concepts. We have a group of view classes, a group of view model classes, and a group of model classes. And we have seen how these interact with each other. And the question is, how do we translate this into an actual system using JavaFX? So let me just rearrange things a bit here. I have indicated the associations here. So the view has a reference. There's an association to a view model. A view model has an association to a model. And we have the bindings between here. These were the sort of specialized observer pattern for JavaFX. And we will get back to this in part 4 to see how these actually works. So over here I have my template, or part of it. We're going to develop it step by step. But I have my view. So this is what I consider the view. It is a JavaFXML file. So this is what you define your actual GUI. And as you have seen before, all your GUI FXML files here must have what JavaFX calls a controller. So this is the very simplest structure. And in this example, I just have them called view1, and you might have called them customer information or buy product or update employee or whatever. But I have the naming convention. I'll get to that. So for each JavaFX FXML file, there must be this class behind it, the controller. Java calls it a controller. I usually stick to the naming convention of using the name of the FXML file and then just appending the word controller. Now I cut it a bit short here in order to make room. I'm going to need the space over here, but this is supposed to be controller spelled out. There is some automatic things happening sometimes, so we actually need this to be called a controller. So I have the name here to indicate that these two belongs to each other. The FXML file and the associated controller here will be bound together by the JavaFX framework. So whenever I have this kind of FXML file, I in the file here specify what the name of the controller is, and then the JavaFX framework will automatically load and put things together here. So the binding means that various JavaFX elements in the GUI are bound to what we call properties in the so my GUI here, my view, these elements are bound to what we call properties in the view model. So these are the bindings that we have we have talked about earlier, and that we will get back to get us to see a more concrete example later on. But for now, the short explanation is that when something happens in the view model, we can see this change automatically in the view, or the other way around. If I modify something in the view, then it is automatically updated in the view model. That's the idea, and that's the binding. For each view, we usually have one and only one view model. You could have multiple view models. I don't know if that makes sense, but maybe it does later on. But usually it's a one-to-one dependency here. One view and one view model. I use the naming convention again of taking the name of the fxml file, here view1, and just appending view model or VM. There's no black magic happening here, so I could just call it VM for short if that's easy for you. So this would be my customer view model or person view model or order view model or whatever. Update car info, something like that. So one view here, these two together are a view. This is how it looks, and this is the functionality behind the view, and they are associated with one view model. Then we have the model part, and the model is usually hidden by an interface. There's a good reason for that, and it may greatly help you when you do the semester project, because when you use interfaces, it will often help you divide the work between group members. The short explanation is that one student could work on this part up here, and then just have you agree on an interface with the methods that you want, and then another student will work on this one down here. And obviously you cannot use the two together until, you may be done with this part, but the model here is not ready yet, so you cannot really test everything completely. But you could create a dummy model and then use that instead, and because they use the same interface, it's easier to swap out. So your view model here just knows about an interface called data model. It doesn't care about whether that's a data model implementation or a dummy model implementation or something else. So the interfaces here, in general, they provide flexibility in your system, meaning that it is often easier to work together on these projects. You are probably also going to need an interface between the classes that accesses your database and the rest of your system, again for similar reasons, so that one person can work on the database and other persons can work on the rest of the system. So that's sort of the general idea of using interfaces to split work between you. You're going to see more about this later in the course. So the model down here contains all kinds of data and business logic and objects to provide this functionality. I have sort of hidden them behind this here because they're not really important for what we're doing right now. It could be anything here. What's important is that I have these two, the fxml file and a controller behind it. There is a view model associated with it, and there is some kind of model interface. And this class is also somewhat important, but the rest over here, that's really irrelevant for the MVVM that we're going to see here. So all of this here is present because we want to show something to the user. In my case, I have just one view, but often you're going to need multiple views. Again, you try to split the views into their functionality. When you hear about the solid principles in your software engineering course, then one of them is the single responsibility. So if we try to look at that, then we should have one view for each type of requirement, basically. Or you could call that a rule of thumb. Not always true, but that's an approach. So each view has its own responsibility. One view may display data in a pie chart. Another view will allow modification of the data, and this is actually the example that we will look at in part 4. A third view may show this data as a bar chart instead. Or another example is that you can view your doctor's appointments in one view and make new appointments in another view and edit your personal information in a third view. So we're going to need multiple views instead of just doing everything in the same view. Then this one will be responsible for way too much. And this is the purpose of the MVVM, that it should be easier to add new views along with your new functionality. So the next step here is I have my simple one view and one view model, and as I just explained, we could have multiple views. So the next step is to expand a bit on the diagram here. The point here is that now I have the classes for one view in place, this column you might call it, and it's easy to add another view without having to touch the existing classes or code. That is at least the intention. So we're going to expand a bit on this example, and here we go. I now have added two more views, and I just removed the .fxml, but the icon here should indicate that this is the fxml file, again for lack of space. And each view has its own column here. View 1 column, view 2 column, and view 3 column. So far they are all sharing the same model. I just have one model, but it might make sense to have multiple model classes, and that could look like this. So now I have a view to, for example, see all customers. I have a view to edit customer information. I have a view to see customer purchases. I may have two models. One is responsible for customer information and updating and modifying and handling that. And another may be responsible for orders and purchases. My view models will need to reference one or both of them. The one about customer information may need to know about customers and their purchases. The one about order history may just need to know about orders or purchases. So it might make sense to split it out like this. In many semester projects, I see only one model interface, and in some cases this may be okay, but it often gets very large, this interface. Maybe it has 20, 30 methods, and sometimes I see the approach that they actually group these methods based on category, and so they might as well have split them out into separate interfaces. So it may be confusing with all the methods here if you group them all into one interface. And if you are multiple students working on the GUI, when one student needs to change something in the model interface, then all the other students are affected as well. But if one student is working on this one and another student is working on this one, then you won't really have any conflicts here. So again, try to separate the responsibilities, just like you do it with the views, and you do that with the interfaces, because that will make it easier for you to work together as a team instead of all four of you are looking at the same interface. So one is programming and three of you are sort of a backseat driving and giving comments. If they both update the interface, you may run into a lot of problems when you try to put the code together. I mean, if you're using Git, then it can probably do some merging for you, but not always successfully. If you're not using Git, then it's even more difficult. I often see the case where one student modified the interface and another also did, and then just overrode what was there. And a lot of programming and hours spent on work would get lost instead. So it's never a good idea to have multiple students modify the same class if you can avoid this. Now, these interface methods can often be grouped, as I mentioned, where each group is independent of others. And in such cases, it may make sense to split the interface into two interfaces, which I have done here. So there's one related to customer data, for example, and one related to order history. So obviously these are just placeholder names. You should call it something meaningful. Customer information controller, customer model, order model, and so on. So one model interface has methods about orders and purchases, and another interface may have methods related to customer information. and that means both viewing and updating the information. At some point in the software engineering course, you're going to hear about the SOLID principles. So this is an acronym, and the S is for single responsibility, and we have that in the views. So the intention is that each view is responsible for one thing only. If one view is bugged or needs modification, then I need not touch any of the others because they are unrelated, and I have separated the view functionality into separate classes here. So my code is nicely separated. I have the dependency inversion here, meaning that you depend on abstractions instead of concrete implementations. And in general, this makes your system a lot more flexible. I can switch out implementations down here without having to change anything in my classes using the interfaces. As long as I stick to the interface, then I can swap these out. So as I mentioned earlier, this will help you collaborate. So one student will do one side, and you will agree on the methods in the interface. You will say what kind of information you need and what methods must be there, and then the other student here will work on the model implementation and provide the functionality that you agreed upon in the interface. So the interface here is a contract between the two of you, so that you provide what each other needs. And while one student is working on the data model, if the student up here needs to test something, this guy or girl can just make its own dummy implementation that just returns some simple dummy objects. So it's going to be easier to swap out your dummy model with an actual one once the actual model is in place and ready. We have the interface segregation principle, which says something about classes shouldn't depend on something they don't need. So if this class doesn't need to know anything about customers, it should not depend on functionality over here. And similarly, if this class is unconcerned about customer data, there shouldn't be any methods related to customers that would just have to be left empty, for example. So again, we try to group the functionality of our interfaces and then split it out to multiple interfaces. We should also be able to more easily add functionality about, for example, different departments in your customer company, because that is just adding another model, a third one, maybe, and maybe another column of view and view controller and view model, or multiple other columns, but we don't need to touch any of the existing part here, or at least not too much. So we have a smaller chance of breaking already existing and working code. And again, students can each work on their own column. You can have multiple students working on view and another student on this view. So it's easier to collaborate when you can split it out. So student A handles view 1 and its associated classes, and student B handles view 2 and associated classes, and so on. So when we apply the SOLID principles to our system, it makes it easier to collaborate and easier to swap out classes and easier to maintain and expand upon. So these are good to keep an eye on when you develop your semester project. All right. So we have sort of the core structure in place here. Whenever you want to add a new view, you just put a new column. Whenever you need some kind of new data, you could add a new model and then bind the things together here with references. So how do we actually do this binding everything together? I mean, we have the core structure of our program, but how do we start something? I didn't see a main method over here. And actually this shouldn't be the responsible of any of these to start the program. Again, we are splitting responsibility into separate classes. So the question is, when are all my classes created and how and in which order? And the next part is to introduce the classes actually responsible for running the program or instantiating everything. So we have the core structure in place. And this is the part that we will do most of the expanding upon once we are doing the semester project. But we need a few helper classes. So I'll just remove this out here, away with you, and then I add these. So this is obviously a class that already exists in JavaFX. I should have capitalized the F. I will regret this forever. So you have a so first we put the classes that launches everything. Basically these two, because this one you don't know what's going on here. This is just functionality that you borrow from JavaFX. So these two classes here are the classes that you will make yourself. So the my application, or whichever appropriate name you come up with, obviously it should be named something more meaningful. Doctor's appointment application perhaps, or warehouse management application, or whatever. This is where most of the initializations happen. This is where most of the initial creation is going on. So we'll see this later in the fourth part where we do the programming example. So this class extends, the arrow for extends, the JavaFX application class, and overrides the start method. The start method is abstract up here, so we have to override it. The start app, or start doctor's appointment app, or whatever, again, just my naming convention. If you agree on some different convention, that's okay, as long as you agree. So the point of having a convention is that you instantly know what each class does. If this is called view model, then I know it's a view model. If it's a controller, I know it's a controller. If I have something called start whatever app, then I know this is where my main method should be located. So the start app has a main method with just one line of code. So this is basically your smallest class in the system. And again, we will see the code for this one later on. Now, I still have a blank space in here, so we need something between the two parts, and let's just move this part a bit. So we have the room to fill in what is needed. Now, all my views up here and my view models down here and all my models, they must be created somehow. So we introduce a few classes to manage and create all of these classes here. And they come here. I create two factories. A factory is actually a design pattern. It is just a class which is responsible for creating other classes. So in my case here, the model factory is responsible for creating and providing the models. The view model factory is responsible for creating and making available the view model classes here. And then the view handler, I do not call this a factory because it also does something a little more. So I've called it a handler. The view handler creates the views and does the loading of the fxml file and initializes the controllers. And it is also responsible for changing views. So if I want to swap from one view to another, then I ask the view handler to do this for me. So this happens here. So these two classes here are all about creating, and this one is creating and also swapping between views. Now for the relationship between our classes, let's add these first. So in the start method here, in the my application class, which is sort of the entry point of the application, in the start method here we create the three classes, these three: the view handler, the view model factory, and the model factory. Now between these three classes we also have a kind of relationship. It comes here. So the view handler has a reference to the view model factory, meaning that in the view handler there is a private field variable of the type view model factory. And I have the initialization code of my start method. You can see that up here. So the view model factory was created in my application and passed as an argument to the constructor of the view handler. So we have that here. The view model factory is created and passed as an argument to the view handler constructor. And the same is true for the model factory, right? We create this and I pass that to the view model factory. So that's the way that I can create the association here between them. The view model factory is given a reference to the model factory through the argument here. And finally, I still have a blank space going on here between my initialization creation part of the system and what the user actually interacts with. And we show the creation responsibilities of our handler and factory classes. It comes here. So I just have a bunch of arrows, and I'm just going to abuse notation a little bit here and combine the arrows. So I'm just going to put it like this. So we see that a model factory creates everything in the box here. So similar cases going on up here. The view model factory is creating all these, right? So usually when the user attempts to switch views, it is the responsibility of the view models to figure out whether you are actually allowed to switch. So we have the input validation and such down here. So if I'm maybe you have some unsaved changes in your view, and you should be warned before closing the window. So you will ask the view here, the view model, may I switch view? And then it returns maybe the true or false or a message or something. So it might give a pop-up and say, you have unsaved changes. Do I want to actually switch the view? So the view model here is sort of giving the approval of the switching. Maybe you're trying to click save and exit, and you should verify that you wish to override some data. And again, that's the view model saying, hey, you're trying to override this data. Are you sure you actually want to do this? So when you're trying to switch the view, the controller will ask the view model, am I allowed to switch it? And then if the view model allows the switch between the views, then the view will call a method on the view handler here, because we have the association here. So that means the controller has a field variable of the type view handler, so we can call methods from here on the view handler. So that's the association going on here. So that means the views, if needed, has a reference to the view handler. Maybe your view does not always need a reference. And in that case, you don't need that one. So I have everything in place now. This is basically our template UML diagram, our template solution. You're going to need at least these two classes. You should have these, and one or more models, one or more view models, and one or more views here. Now, depending on how big your system is, and in your semester project, it might make more sense, but in the exercises when we do the session, maybe you just have one model, and then it might seem like overkill to create a model factory to just create this one model. So a bit of a too much administrative work and overkill to have a class that basically does very little. And the same thing for this one. So you might be tempted to just create the view model over here or the model over here and then pass them to the view handler. But I strongly recommend that you stick to the template here. just so that you get used to how to set it up. And in your semester project, if you are going to need more models, then it's easier to expand on the factory here. If you need more view models, which you most likely will, then it's easy to expand on the factory here, rather than creating a bunch of all your view models and models over here and passing it to the view handler. So there's a intention, and I believe it's a good intention behind the factories and the handler here, even though in the exercise they do very little. So try to stick to the template, follow it, and get familiar with it, because we have tried to design it in a way so it's easier to expand upon without making too many changes. That's the idea. So this is the end of part 3. Again, thanks for watching. We have the concepts in place. We have the idea of how communication happens in part 2, and now we have the template UML. So all our JavaFX applications will be structured in this kind of way. And then in future sessions we will see how to add some extra client-server networking functionality. We can expand upon this template without modifying it too much. So again, a benefit of creating a well-structured system that we can easily expand upon in the future without meddling with existing working code. That's the intention. And hope to see you in the 4th part.